All right, today we are going to be building some wooden sawhorses. I use sawhorses all the time in my shop. I use them for like temporary workbenches or places to glue up panels or to, just store material like I have back here. And I have like 6 pairs of these cheaper ones, then I have 2 pairs of these more expensive ones, and they work great, but I don't want them to be made out of metal. I want wooden ones, so that's what we're going to do today. There's only 12 pieces to make a set of these. It's really not a lot of wood. You can probably make these for under $10 a set. So no more talking. Let's start cutting some wood. I'm going to get my wood roughly broken down, and I'm going to start milling it up. I recorded the voiceover for this whole video, and I was so happy that I finally got it done. And then I listened back to it, and it was so boring. It was just me telling you exactly what I'm doing. So I was like, man, I cannot let this be part of the video. So I'm going to redo this whole thing, and that's what this is right now. The wood I'm using for this build is English walnut. I use a lot of English walnut in my shop because I just build a lot of pieces with it, and I have a lot of leftovers, and that's what this stuff is. It's some super sappy English walnut. With all of our stock cut down to its rough length, we're now going to rip it down to its rough width. And everything's going to be 3 inches wide. I designed it that way to keep it really simple. We're going to do the rips on the bandsaw. It's much safer on the bandsaw when the wood is in its rough state because this isn't perfectly flat, and if you do it on a table saw, it could pinch on you if the wood falls down and pinches the blade. I said pinches it twice, and I probably could have done a better job of explaining that. But basically the wood can fall down if it's not flat. And what happens is it grabs the blade and it'll shoot it back at you or shoot it up. And it's just really scary. And really, the real concern isn't that the wood gets shot back. It's that you're going to poop your pants. And as you can see right here, I'm wearing shorts. So I really could not afford to poop my pants. That would have been a nightmare. All right, back to the woodworking. I like to break down my pieces into rough sizes. It's a pretty standard practice. I like to make my pieces a little longer, a little wider, and a little thicker while I'm milling them up. This gives me some wiggle room when I'm turning some of the wood into sawdust. Like I said, bandsaws are just a little safer to break down the wood than it is to break it down to width on the table saw there. It will pinch, and it really is scary. So I've got everything down to my rough sizes, and I'm taking them down to my final sizes, and that means, jointing and planing and ripping on the table saw and then cutting them down to length on the chop saw, which is what I'm about to do right now. I've got all of my material down to its final width, length, and thickness. And now let's talk about the thicknesses. All of the material is 7/8 of an inch thick, except for the uprights or the legs. I took those to 3/4 of an inch thick. And the reason is because when I wanted to attach them into the foot or the base part, I wanted to have a little reveal on that so it's a little narrower than the rest of the stock. The next step is to do the layout and the markup for the joinery, which is honestly my favorite part. I'm not going to use any of my specialized tools because I think that this project should be something that anyone can build, and I think it would help anyone's wood shop. I definitely forgot to hit record when I first did the markup on this, so that's why there's marks there already. But I'm not really sure why I use this 2-ruler method. It worked for some reason in my brain. But anyway, the goal here is to mark up a space that has 2 inches between them. And I'm using a 3/8 bit to get a 3/8 wide mortise. So I realize I probably shouldn't be dropping woodworking specific phrases without explaining them. So what we're looking at here is a mortise. And this is a traditional mortise, and it goes partially into the wood. It's basically just a hole in the wood. You can also have a through mortise where the hole goes all the way through the wood, like this. The other word you're going to hear me use is tenon, and mortise and tenon go together like peas and carrots. In fact, the tenon is almost the opposite of a mortise in the sense that it is a protrusion coming out of the wood, whereas a mortise is a hole in the wood. And the mortise and tenon go together perfectly, and they make one of the strongest joints in woodworking. Okay, now back to your regularly scheduled video. I'm using the edge guide on my router, and I just set up clamps so that when I moved my bit to the edge of those lines, the clamps stopped them. So they're my positive stops so that I only go 2 inches wide or stay within those lines. I wanted to do a 3/8 wide mortise because I was going to do a 3/8 wide tenon, and that's because the material is going to be 3/4 of an inch that's going into that. So that makes the tenon exactly half the thickness of the material. And there's all 4 of them. Basically all I did was make it so that the center of that mortise was on the very center of those leg pieces, and that's what those 4 pieces were. I'm using a 1-2-3 block to set my stop block to 1 inch. That makes it so my tenon is 1 inch long. And I did that because I made my mortises just a little bit over 1 inches deep, and that leaves enough room behind for there to be glue in there. Typically, I would do these tenons on my bandsaw. It'd be a lot faster, frankly, but I know that more people have table saws than have bandsaws, so I wanted to do this in a more relatable way. All I'm doing here is removing the material from the board so that I can expose the tenon. I need the tenon to be 3/8 of an inch thick, so I'm going to remove 3/8 of an inch of material because this is a 3/4 inch board. So that means I need to take 3/16 of an inch off both sides. It's not rocket science, it's very simple math, and sure enough, unlike me in high school, it fit right in. With the material removed on the long face of the tenon, it's now time to remove the material on the short face of the tenon. And you notice I don't move my stop block at all because I want my shoulder of my tenon to be the exact same all the way around. My tenon is going to be 2 inches long, just like my mortise, and my piece of wood is 3 inches long, so technically I'm removing a 1/2 inch off either side. But instead of getting that close to it, I'm using the 3/8 setup block because I can always sneak up on my cut. Since I used a router bit to make the mortises, the corners of my mortises are rounded. And since I used a table saw to make the tenons, they're square. So I need to make them round, and I do that by using a roundover bit, believe it or not. And in this case, I'm using a 3/16 radius roundover bit because that is the radius of a 3/8 bit. Since the roundover bit can't round over the tenon without destroying the shoulder all the way down, I grab a chisel and I start doing it by hand. And I'll be really honest with you, this is incredibly satisfying, especially with a really sharp tool. I've got my mortise on my foot and I've got my tenon on my upright. So the next step is to put the mortise in the upright that the lower stretcher is going to go in with the through tenon. I'm going to use the same process I used with the router. I'm going to set up the edge guide and the depth stop and all that stuff. But the next thing I got to do is do all my markup and my layout. I made that line at 8.5 inches from the shoulder and then the next one at 10.5 inches from the shoulder. That gives me, a 2-inch space between them for the tenon to go in. One of my favorite things about these sawhorses, aside from them being actually super functional, I've been using them for a couple of weeks now, is that you get to do so much cool joinery. It's a mortise and tenon again, but this is a through mortise and tenon, and those are just inarguably super cool. I think what's so cool about using a through tenon on a sawhorse is that you're making a statement, and it's a design choice for sure. You're choosing to show off the joinery and the craft of woodworking. But you're also saying, hey, this is a really nice joint, but I'm still going to use it on something like a sawhorse that is really a utility item because it's the right joint for the application. And it just is something that really shines through, and it's a timeless embodiment of the craft. Since I'm going to do a mortise all the way through my piece of wood, I'm using that piece of wood to set my stop block for the depth of my tenon, because I'm going to have my tenon go all the way through the piece of wood. In an attempt to make the tenoning process as approachable as possible, I also kind of made this the most miserable process for this entire build. This is awful. It takes so long to do these tenons like this. Any other tool would make this fast. Well, not any other tool. A screwdriver would not make this faster, but a bandsaw would definitely make it faster, or using dado stack or something, anything else. Looking back, I should have done the first set of tenons on the table saw like this to show this method, and then done this set of tenons on the bandsaw to show that method. I could have even done some of these on the dado stack. I don't know what I was thinking. I was just trying to stick to the course, but anyways, there's a bunch of ways to skin a cat, or cut a tenon, or cut a mortise. There's a ton of ways to do all these things, and whatever you have accessible to you is the right way. So don't think that you have to do it this way, because you really don't. You can do it whatever way works for you. Once again, I'm cleaning up that round over with the chisel because, as often is the case, a hand tool is the best tool for the job. In fact, it's really the only tool for the job there. These joints are nice and tight, which I'm really happy with because I'm not going to be using any glue for this. And that's not necessary for how you do it. You can do it with glue for sure, but I wanted this to have no glue, and I'll explain my thought process on that later when we get to the joinery of the upright and the foot. I've set my blade to 1 inch high because I want to make a 1 inch deep cut, and I've taken my upright and I've set it upright on the crosscut sled, and I'm making cuts on it from the middle out. And what I'm doing to make sure that it's the same distance from both sides is I'm putting the board down, cutting it, and then flipping it around and cutting it again in the same spot. So I'm basically moving the cut from the middle out until I get to the exact width that I want, which is the thickness of that other board. Here I am cutting the notch for the other side of the joint on the partial bridle joint, which I think that's what it's called. I'm really not 100% sure, but I can't use the flip around method because that notch isn't on the center of the board like it is on the other one. I didn't want the feet to just be rectangles, so I added a 15-degree miter on both ends of them and made them into a trapezoid, which gives it some nice dimensionality. I also decided to add a reveal on the bottom side of the foot so that if there was ever like any unevenness on the ground that it's sitting on, the smaller amount of surface area would make it easier to even out. When I make these again in the future though, I won't make this reveal so big. I think I went like a ½ an inch on these, and they really only need to be like 1/4 of an inch or 3/16 of an inch. A little goes a long ways on these design details. I just eyeballed where I wanted the cut to be, and then I set a clamp to where I want it to be for my positive stop. And that makes it so I don't have to do any measuring. It's just reference cutting at that point, which is my favorite because tape measures, I always mess up with tape measures. I grabbed a straight edge and I drew a straight line between the two kerfs. And then I took the piece over to the bandsaw and I started removing the waste. I use the fence here to make sure I'm following a straight line. Then I just flip it over and I cut the remaining part of the waste off. And now I'm ready to take it over to the router table and put a straight edge on there, put some double-sided tape down, and flush trim any remaining material away so that it looks perfect. Again, because router bits are round, they leave a radius on the inside corner, and I want it to be a sharp inside corner, so I'm going to grab my chisel and I'm going to clean it up and make it look really nice. Somewhere along the line, I decided I wanted to do this whole thing without using wood glue, and with that, I decided that I wanted to join my mortise and tenon that connects my upright to my foot with a drawboard mortise and tenon. Now let's talk about what that is. If you took a mortise and tenon and you drilled a hole straight through them while they're connected together, you just have a straight hole through them and you could put a peg in there and it would hold it together. But if you offset the hole in the tenon just slightly towards the shoulder, when you put that peg in there, it's going to draw the joint together really tight. And that is what a drawboard mortise and tenon is. It's really cool because you don't have to use clamps with it. I took the plugs that I cut out with the plug cutter on the drill press and I took it over to my disc sander, which you can see on the left with the spider webs there. I use this thing all the time. Honestly, it is a really great disc sander for what it is. I got it from Harbor Freight like a million years ago, and it's just worked really well for me the 4 times a year I use it. Because the tips of the plugs are sharpened to somewhat of a point like you would a pencil, they go through the drawbore really easily. One thing you want to make sure though is that your grain is really straight on your plugs. Half of my plugs ended up breaking because they didn't have straight grain, but the other problem was that the offset hole in the tenon was a little bit too offset, so that doesn't allow the plug to get through. So I had to put some of them back together, and then I took them over to my Moxon vise and filed out the offset hole so that I could easily get a plug through there. Once I got all my plugs set, I flush trimmed them with my little flush trim saw, then I cleaned them up with a chisel, and then went back again with a hand plane and got everything really nice and smooth. I then took the lower stretchers that are going to have the through tenons over to the bandsaw and I cut a kerf on them exactly the same distance apart. I just used the fence so that I can have my wedges go in there. And I know I said I was going to do this build in the way that people without bandsaws could do it. You can do that kerf with just a handsaw, and you could do it with a tenoning jig on the table saw as well. Then I took it over to the drill press and I added another relief for the kerf so that when the wedges do go in, the grain doesn't just snap and I don't break the tenon. These wedged through tenons, I simply did them because I like them. They do serve a purpose. I mean, they allow me to, actually I can take the wedge out and I could remove the tenon if a piece breaks. And I didn't use glue, so I can facilitate that as well. I can take these pieces apart and I can replace them as needed. And these are going to get used. They're shop furniture. I did flush cut everything off for the through tenon, though I wish I had kind of left it a little proud. I think that would have been a cooler look for this. But the functionality is still the same, and it's going to be a great piece of shop furniture. And continuing with the no glue philosophy here, I decided to just drill some holes in the side of the uprights and set some screws in there so that I can take it apart as those upper stretchers get destroyed over time. I can just put new ones on there and replace them out. They're just really sacrificial at that point. After cleaning up everything with hand planes and breaking all the edges with my little small hand plane there, I applied a few coats of shellac to everything. And then after that, once it was dried, I kind of knocked it all back with some 600 grit sandpaper, and I put some furniture wax on there. The furniture wax is a great barrier for the day in and day out use, but it's also really nice because I am going to use these to glue boards up on, and I want that glue to just sort of fall off the piece. So there's that wax going on right there. This project was so fun to build. I loved every second of it and I had a ton of fun. And now I have some really functional shop furniture that I can use all the time. And I just like how these things are laid out and how you can put wood on them. You can put wood across the lower stretchers or the upper stretchers. And they're just such a cool piece. And I'm so glad that I made these.